Hi guys, how are you all? Hey, you're able to hear me? Wait, I'm not able to hear you at least. Are you all talking? Hey Krish, you're able to hear me?
Yeah.
Okay, good. What are you doing in school?
We just started Unit 3A yesterday, and it's gonna be like the unit circle unit.
Oh, so it's easy. Okay. Are you able to, meaning at least are you familiarized with the content?
Yeah.
Okay. Meaning, did you confront what we learned here? That's what I meant to ask.
Yeah.
Okay, good. Lopa, what are you doing in school, ma?
We just came back, so we haven't learned anything yet, but we are starting a new unit on Friday.
Oh, okay. Okay, that's good. Hmm?
That's late.
Okay, let's go ahead. Why you're not able to see my screen? You're able to see my screen now, right? Good.
Miss Priya,
Yeah, ma.
I had a question on this type of problem that they taught us in school. Could you do that at the end of the class?
Yeah, you want to send it in WhatsApp?
Yeah.
Anything I can do. Yeah. Send it in advance always, but it's absolutely okay if you send it now. Send it. Okay. What are you doing in school, Madhwani? Dhwani, what are you doing in school?
We started the periodic functions and we're gonna start, I think, radians and like the unit circle tomorrow.
Oh, okay. So I'm going into sine and cosine graphs. Let's see. Are you sending it, Dhwani?
Yeah.
Okay, you send it. Okay, let me go ahead with the sine and cosine graph. Do you all remember how to draw the unit circle, guys? If you forget, right, meaning you will have to remember I said. So I'm going to go ahead with the revision of the unit circle first. So guys, this is just a unit circle of radius 1, right? So that being the case, even if you forget, right, meaning how to remember this unit circle was one question that I already got from one of you. So this is a unit circle, means radius is 1. So let's start here. What is this? 1 comma 0, right? This is minus 1 comma 0. This is 0 comma 1. This is 0 comma minus 1. Any questions still here? Now you all know this is 0, right? When you go around pi by 2, pi, 3 pi by 2. Any questions still here? Okay, now I'm going to split it into 45 45s. You know 45 45s means, see here. I'm going to split it into 45, means 0 to pi by 2. So this one is pi by 4. You see, this one is pi by 4. Again, when you go to the next pi by 4, what happens? 2 pi by 4 it becomes. But we write it out as pi by 2, simplified form. So I don't use this at all. Next, from pi by 2, I add another pi by 4. See, I add another pi by 4. When I add another pi by 4 with pi by 2, what happens? What is pi by 2 plus pi by 4? When you think about it, you have to make the denominators the same, right? So what does that become? It becomes 3 pi by 4. Any questions still here? Now, we add another pi by 2. That becomes 4 pi by 4, but simplified form I write it out as pi. Then it becomes 5 pi by 4. This is 6 pi by 4, but in simplified form we write it out as 3 pi by 2, and this one is 7 pi by 4. Any questions? This is 8 pi by 4, which is again 2 pi. Any questions still here? Shagvi, are you following, ma?
Yeah.
Till here you followed, right?
Yeah.
Okay. Now, coming to our values, right? Meaning, what are the values at these points? Okay. One thing what I would like you to memorize is, this is root 2 by 2, comma root 2 by 2. This is first quadrant, both will be positive, right? Now, the same points, meaning, what are these points? I am considering a point P, which is represented as x comma y. So, that point, the x coordinate is minus 3 by 2. What is this x coordinate? X coordinate is r cos theta comma r sin theta, remember? So, the radius is 1. So, the first value gives you the cos theta value. The second one gives you the sin theta value. What is cos theta? The horizontal displacement to that point. The y value gives you the vertical displacement to that point. So this one is cos theta, this one is sin theta. Now when it comes here, right, meaning now with this theta, right, so this is theta is pi by 4, right. So the cos pi by 4 is this value, sin pi by 4 is this value. Any questions there? Okay, now when it comes to this quadrant, what gets negated? This x. When it comes to this side, the x value gets negated. So this is minus 2 by 2, minus root 2 by 2, and then root 2 by 2. Got it? So now here, this one is cos 3 pi by 4 is a negative value, sin 3 pi by 4 is a positive value. Any questions there? Any questions there? Okay, we'll go to the next. Okay. So now, how do I come here? X is also negative, y is also negative. So see, cos 5 pi by 4 is also negative, sin pi by 4 is also negative. Coming to 7 pi by 4, x is positive, y is negative, right? So x is positive, y is negative. Any questions here? Is that easy? The next thing what we do is, we split it further, meaning we want the 30, 60, 90s to come in. So for that, I will draw a line like this. So this becomes 30 degrees. 45, 45, 45, we were splitting. Now I'm going to split it into 30, 60, 90. See? You got it? 30, 60, 90. So, now how do I write that? 30 is translated to pi by 6. We are splitting the entire unit circle as pi by 6, pi by 6, pi by 6, pi by 6. So you don't have to really memorize. When you think about it, pi by 6. This can be written as 2 pi, hold on. I made a mistake here. Okay. So this one is pi by 6, 30 degrees. Then I add another 30 degrees here. This is the 60 degree. Remember? 60 and this is 90. All the angles here are same. 30, 30, 30. You see? So now pi by 6 gets added to another pi by 6. So what that will become 2 pi by 6. But I don't write it out as 2 pi by 6. Instead, I have that line. Wait, I don't want to. I want that line, but I will not write 2 pi by 6. Instead, I'll go ahead and write pi by 3. Remember these two you need to remember, okay? Pi by 6 is always near the x-axis. Pi by 3 is always near the y-axis. You have to remember that. Now, pi by 1 pi by 6, 2 pi by 6. This is 3 pi by 6. But you don't write 3 pi by 6, but you write 3 by 6 becomes 1 by 2. So pi by 2. So I keep on adding 30 degrees now. Now this is what? 4 pi by 6. How can I write 4 pi by 6? 2 pi by 3. You got it? And then this is 5 pi by 6. Then this is 6 pi by 6. That's why 6 pi by 6 is nothing but a pi. Then this one is 7 pi by 6. 8 pi by 6 you write it out as 4 by 3. 8 by 6 is 4 by 3, right? 4 pi by 3. After that 8 pi by 6, 9 pi by 6. But you don't write 9 pi by 6. You write it out as 3 by 2 pi. Then you have 10 pi by 6. 10 pi by 6 is 5 pi by 3. Then 11 pi by 6. Then this is 12 pi by 6, which is 2 pi. Any questions? Any questions? Okay, now how do you remember the values? The values are hard. No, they're not hard. Okay, what you need to remember is this set of values and this set of values, root 3 by 2 and 1. If you can remember only these two set of values, it's very easy. Here it's going to be the negation of that. What happens here? This value, right? Meaning this one. Both will be negative. Root 3 by 2 and 1 by 2. I'm sorry, ma'am. Both will be negative. Here x will be positive, y will be negative. Any questions? Now, how to remember the last one? The last one, that means here, this gets interchanged. This becomes 1 by 2, root 3 by 2. As a result, this becomes minus 1 by 2, root 3 by 2. Here both are negative. Minus 1 by 2 minus root 3 by 2. Here, one is positive, one is negative. Any questions? Any questions? Slowly you have to get this to your brain. Shragvi, did I answer your question? Would you be able to write it out by yourself?
Yeah, probably.
Okay, where are we? Where are we missing? We will, when you go out of this class, you should know unit circle by heart. Where can I help you? Can we do it from the start again?
Yeah.
Sure. Tell me, Madhwani, which question did you want, Dhwani, in that? Is there
It was
a
like just cause our teacher wasn't here, so I wasn't able to ask her this, and there are like multiple points that could be the right answer for this as well. So I just wasn't sure if my points were right.
Okay. No.
It's like-
In today's class, you'll get it, ma.
Yeah, like I just want to know the points. The decreasing and stuff is easy. I don't like that stuff's fine. I just want to know part A.
Okay, at the end, we'll discuss that.
Okay, thank you.
Yeah, I'll definitely discuss that, okay. Okay, now, can I go ahead and delete this? Okay. So how do we start? Shragvi, where are we missing? Meaning, you can as well help me, guys. Did you all memorize already unit circle, Dhwani?
Like in school?
Ah.
No, we're gonna start that tomorrow.
Okay, so let's go ahead one by one. You tell me. You guys, please tell me, guys. So what should I start with here? Anybody, please volunteer.
1, 0.
Because it's for you. There's no point in you keeping quiet. If you don't know, I'm going to help you. When you go out of the class, memorize it and go. You'll be amazed at how you follow in school. Go ahead. 1, 0. This one?
0, 1.
0, 1. This one you all know. 0, minus 1, 1, minus 1, 0. That you know. Now let me start with 0. This one is, what is this angle?
90 degrees.
Yeah, always remember this half a circle is a pi. Okay, this is pi by 2. We are going to only talk in radians hereafter. Okay, 0, pi by 2, pi, and then what is this? This is again 2 pi. So half of it is what? Pi and 2 pi. What is half of it? 1.5, right? We don't say 1.5. We write it as 3 by 2 pi. Okay, now 45, 45, 90. We are going to split it 45, 45, 90 degrees. So 45 degrees, see, 0 degree is 0 radians, okay? 45 degree is pi by 4. 90 is pi by 2, okay? Then 270 is 1.5, right? 3 pi by 2. These are all in degrees. This is in radians. Then 360 is 2 pi. This is what you need to know basically. Okay. So this is what I am doing here. So this 45 degree is pi by 4. Okay, when you think about it, you don't even have to memorize this. See, 1 pi by 4, 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, 7 pi by 4, 8 pi by 4. Does that make sense, Ragvi?
Yeah.
So this is 3 pi by 4. This is 4 pi by 4. I wrote it down. This is 5 pi by 4, 6 pi by 4, 7 pi by 4. Okay. Any questions? Okay. Now I'm going to write down the values. What are the values here? As I said, right? Root 2 by 2, root 2 by 2. This one you're going to just based on the quadrant. What will this be, Advik?
Negative root 2 by 2, root 2 by 2.
Comma root 2 by 2. If you make a mistake, I'll tell you. This one?
Both negative.
Yeah. This one?
Root 2 by 2 and then negative root 2 by 2.
Root 2 by 2. So 45 is done. We are moving on to 30, 60, 90. That is where the tricky part comes. But always remember, whatever is near the x-axis is pi by 6. Whatever is near the y-axis is always pi by 3. Okay, the other set. Now, what are the degrees you need to memorize? 30, 60. 30, 60. 30 degrees is, see, half of this 0 to pi by 4. I'm sorry. Okay, it doesn't become half. So basically, 0 to 90 degrees pi by 2, right? So divided into 3 pieces, meaning pi by 2 is divided by 3 means this is pi by 6. This is 2 pi by 6 because 30 plus 30, another 30 you're adding, right? 2 pi by 6, I can write it out as pi by 3. That is 2 pi by 6. Then this is 3 pi by 6. Then you see you need to add another 30 degrees, right? So when you add that another 30 degrees, it becomes, see, this one was pi by 6, this is 2 pi by 6, this is 3 pi by 6, this is 4 pi by 6, but you write it out as 2 by 3 pi. So let's write it down. This is pi by 6. You add another 30 degrees, it becomes 2 pi by 6. Then this is 3 pi by 6. This is 4 pi by 6. 4 pi by 6. Then the next one is 5 pi by 6. You don't want to write 6 pi by 6. It's already there. Then 7 pi by 6. Then this is 8 pi by 6. Please don't touch the 45 degree angles. This is 9 pi by 6. This is 10 pi by 6. We don't write 10 pi by 6. That's where we write 5 by 3. Okay. Then this is 11 pi by 6. See, when you think about it, all the pi by 3 angles are near the y-axis. All the pi by 3 angles are near the y-axis. Did we do a mistake? Yes. So all the pi by 3s are near the y-axis. Pi by 6 are near the x-axis. If you can remember that, automatically you will get it correctly. And the last one is marking their values. Cos of that, sine of that. What is the cos of that, sine of that? The x value. See, suppose P is a point, right? The x and this is the y value, right? How do you indicate this is x comma y? Or you can write it out as cos theta comma sine theta. So here only thing you need to remember is root 3 by 2, 1 by 2. Now you can keep on exchanging that. Minus root 3 by 2, 1 by 2. Minus root 3 by 2, minus 1 by 2. Then here root 3 by 2, minus 1 by 2. Similarly, this gets interchanged for pi by 3. 1 by 2 root 3 by 2. So this is minus 1 by 2 root 3 by 2. And then what else? So here we did not do it in here. So this is going to be both negative. This is going to be 1 positive, 1 negative. Any questions? Any questions? So basically what you need to memorize is 30 degree is pi by 6. 60 degree is pi by 3. These are the things you will have to memorize initially. Okay. 45 is pi by 4. These three you need to know. Now, can I move on? I'll bring up the unit circle, put it in here. I don't want to have this messy unit circle. Okay, for now I'm going to bring the unit circle, put it in here. Okay, I really need to discuss something on unit circle now. So let me give a minute. Did you guys get Shragvi, are you a little more familiar with unit circle now?
Yeah, thank you.
You will be able to do it by yourself?
Yeah.
Okay, good. Let's see. 1 second, guys. I just want to bring up the unit circle and put it in. Give me 1 minute when I do that, okay? You'll have to be a little patient. Unit, yeah, I have it here. Yeah. I don't know whether I have a good unit circle to get it for you. I'll find a good, I have it. A good unit circle. Oh, we are going to do something about this, okay? We are going to draw some graphs. So I really want a nice unit circle. Yeah, I have one. Okay, let me use this unit circle. Okay, do you all see my unit circle? Guys, you all see my unit circle?
Yeah.
Okay. You know what? I'm going to plot it into a graph. Okay. Okay. Sine I'll do. Okay. Cos you guys are going to do and show me. Meaning, we were only talking about what is cos pi by 6 value? Root 3 by 2. What is sine pi by 6 value? 1 by 2. What is cos pi by 4 value? Root 2 by 2. What is sine pi by 4 value? Root 2 by 2. What is cos pi by 3 value? 1 by 2. What is cos pi by 3 value? Root 3. I'm sorry. Sine pi by 3 value. Root. You know this now from the unit circle. Okay. Without even memorizing, you know how to fit in as well. If you even forget, this you'll have to take it to your brain. 100%. Okay. Meaning tomorrow if I come and ask you what is sine 4 pi by 3? What is sine 4 pi by 3? Immediately your brain has to go here and it should remember that it is sine means it's minus root 3 by 2. To that level, this has to go into your brain. Okay. But see, if you're able to draw this quickly, right, using whatever we have gone through, right, you don't even have to memorize. But at some point, you will get it. You'll get it to your brain. Okay. So here, what I'm going to do is I'm going to convert this into a graph. Okay. I'll draw the graph and I'll show you a video as well. I've taken a video and kept. I don't know whether I had the link correctly, but let me see whether I can get it now. I have a link that I searched out of YouTube, so that clearly shows how this graph converts to a, meaning how this unit circle converts to a graph. You know, now what I'm going to do is for sine, I'm going to draw the sine theta graph. Okay. Let's see. Sine theta is a function, right? Meaning we have drawn several function graphs. We have drawn linear graphs, quadratic graphs. Like that, sine theta is also a function whose values are these. Right? I'm going to write it down as a table. See, linear graph as well, we started from a table, right? These values form the sine theta graph. Let me see what are these. I'm going to show you how you're going to do cos theta, guys. Okay? You're going to show it in the video. So let me go ahead and put theta. Okay? And then sine theta. Table only we had, right? Initially, you remember? So same table I'm going to do. 0, 0. We'll start with 0. And then what? Pi by 6. And then what? Pi by 4. I'm just copying from there. Pi by 3. And then what? Pi by 2. And then what? 2 pi by 3. And then what? Okay guys, I'm sorry. I'm going to make this into a big table. Otherwise we can't do. Okay, I'm going to put it into a big graph. Okay, theta, sine theta. That's not enough, so I'm going to do it here. Okay, pi by 6. Then I have pi by 4, pi by 3. Then I have pi by 2, 2 pi by 3, 3 pi by 4, 5 pi by 6, pi. Do you have any questions how I am copying? I'm just copying these values. Do you see? And then from pi, right, I'm copying 7 pi by 6, 5 pi by 4, 4 pi by 3. You don't need this many, okay, 3 pi by 2, and then 5 pi by 3. I'm just showing, oh, we are copying it from there. That's all. 7 pi by 4, 11 pi by 6, and then 2 pi. I'm copying all the values. Now the sign values are 0, 0, then 1 by 2, root 2 by 2, then you have root 3, you have, oh my god, what did I do? I'm sorry. While copying, I'm making mistakes. 0 I did not include, right? So let me start at 0, 0 value, pi by 6 is 1 by 2, root 2 by 2, root 3 by 2. Any questions still here? Krish, are you following how we are doing this?
Yeah.
Root 2 by 2, 1 by 2, then you have a 0. See, this 0 I copied, then 1 by 2, root 2 by 2. Minus 1 by 2, minus root 2 by 2, then you have minus root 3 by 2. Then you have what? Minus 1, and then you have what? Minus root 3 by 2, minus root 2 by 2, minus 1 by 2. Finally, you have a 0. Now, I'm going to put it into a graph format here. Okay, this is my 1. What is the highest value? When you look at it, the highest value of the sine graph is 1. The lowest value is a minus 1. Did you see that? Okay, now I'm going to have pi by 4, pi by 2, and then what? 3 pi by 2, 3 pi by 4, let me have pi by 2, and 3 pi by 4, let me have, then I can have a pi, then I can have a 5 pi by 4, only the 45-degree angles I'm taking, I'm not taking everything. Okay, pi by 4 I took, then I took 3 pi by 4 I took, and then I took pi by 4, pi by 2, 3 pi by 4 I took, and then pi I took, then 5 pi by 4 I took, then I'm going to take 3 pi by 2, 1.5 pi, 7 pi by 4, and then 2 pi. Any questions? Any questions? Okay, so those values I'm going to plot it into an ordinary graph, guys. This represents my theta, this represents my sine theta. Okay, so at 0, right, what is my sine value? 0, 0. I'm going to plot it. Come to pi by 4. What is this? Root 2 by 2 is 1.414 divided by 2, which is 0.707. So 0.707 means this is 1, this is a minus 1. 0.707 is somewhere here. Can I say 0.707 is somewhere here? Pi by 2 I'll come to. It is a 1. Right? And then what do? I go to pi. Okay? It is a 0. But in between I would like to know, again 0.7, right? 0.707. Now again, I go to what? This one. Minus 0.707. Minus 0.707 is somewhere here, right? Can I say here? And then 3 pi by 2 is a minus 1. Then what do you have? 7 pi by 4, again minus 0.707 and a 2 pi. What happens, guys? What graph do you get? Do you see the graph? It starts at 0, comes to the same 0 point, which we defined it as a period. Do you see? One cycle of the graph went from, see, when I go from here to here, I went from 0 to 2 pi. Same thing I'm doing, 0 to 2 pi. On a coordinate system, I'm doing the same thing. Whatever, I went around a circle in a unit circle. I'm transforming that. See, this point in the graph translates here. This point in the graph translates here. And this point in the graph translates here. And this one pi translates here. Am I making sense? Parvini, did you get it?
Yeah.
So see how it is getting translated. The unit circle sine values are getting translated like this. So at 0 you have a 0. Sine graph always starts at 0 and has a period of 2 pi, and it attains a maximum of 1 at pi by 2 and a minimum of -1 at 3 pi by 2. Any questions? This is called a sinusoidal graph. Why? Any transformation on this, which is it's oscillating. Do you see? Basically the graph goes like this. It goes like this. Do you see? And it is always 1 on top, -1 here. There is no transformation here. This is the actual parent graph. We did graph for y equal to x, y equal to x square, y equal to x cube, y equal to 1 by x. All these we did graphs. But we never did a sinusoidal graph. Here it is y equal to sin x. This is another new function that you're learning, a trigonometric function. You drew the unit circle, you mapped the unit circle into a graph and you got a sinusoidal wave, sinusoidal graph. Any questions? Which oscillates between positive and negative. Any questions? Now guys, can I erase this? I really want you to draw the graph for cos x. Can you try? Can we try the graph for cos x? Guys, can you try? Shri, I want the video to be on Shri.
Okay.
Guys, are you all ready to do the cos graph? Hey, yes, no, please tell me, guys. Advik, will you be able to do the cos graph?
Yeah.
Okay, so let's see how you draw the cos graph. Where does it start? Where does it end? I'm going to see. I'm going to erase this. You're going to make a table. Literally, you're going to make a table between theta and cos theta. What are the... See, there's nothing for you to remember and do even. Okay, these are the cos theta values. The x values are the cos theta values. So, you're going to copy all the cos theta values around the unit circle. And each theta values you're going to remember, pi by 6, pi by 4. You're going to make a table of x and y, input and output values, and then completely graph that input and output into a graph. But what I want you to do is for cos x, only these values, not the y value. Sin I showed you for the y. Can you do it for cos? And show me the graph. If it is difficult, I'll definitely help you. But I would really like you to try. Or if you're stuck, then let me know. I would be the first person to help as well. I'm not expecting magic, but at the same time, I want you to figure out. In the meantime, I'm going to take a look at what the question was. Oh, why don't we do this soon after this question? Dhwani, exactly that's what we are doing now. This question is what we are doing now. Did you realize that, whatever you're asking?
Yeah, I kind of like got it a little, like I kind of connected the dots a little bit with that.
You're able to connect both, right? See, you are given a merry-go-round. I showed you a unit circle. The merry-go-round, they are plotting it into a graph. We plotted the unit circle to a graph. Let's try that, guys. Show me the graph. You're going to do, please. Meaning, if you are able to do these nicely, it should be easy. If you don't know as well, please let me know. Where can I help you? I'll help you. But I want you to figure out the graph for y equal to cos x and show me on the video. With proper angles, their values. You can take your time though.
Miss Priya, I'm kind of confused. Here on me, Miss Priya.
Sorry. Yeah, go ahead. Where are you confused?
I don't know. I'm not able to solve it. I don't know why.
Did you put the table?
No, I'm doing that right now.
See, it is just okay. It is just like see. Okay, suppose you have y equal to x, right? You know, okay, some of the values you know 0, 0, 1, 1, 2, 2, 3, 3. You'll draw the table. How do you graph this? Simply, if I say graph this, you'll not know anything as a sixth grader, right? But how do you graph this? You put some points, frame up a table, and then plot the points as 0, 0, 1, 1, 2, 2, 3, 3. You'll draw the line. That's what I'm asking you to do for y equal to cos x.
Oh, okay. I can't do that. Right?
So you have the values I've given you, meaning I'm not even asking you to
Yeah.
remember and write. But I'm telling that cos means you have to take this. Sine I already showed you. Cos is the x displacement. So cos all the x values, these are the y values, cos theta values. X values are these values.
Yeah.
But the biggest problem with this is, for you, you're all new to radians, so you might not know what to do. But see, remember, I can put down values as well for you. This is 0, this is 30, this is 45 degrees, this is 60 degrees, this is 90 degrees. 90 plus 30 is what? 120, 145, right? 120 plus 30 is 150, 180, 180 plus 30, 180 plus 30 is 210. Then again another 30 is 240, but in between you have 45, right? So that is 225, right? And then you have 270. So these are in degrees. I'm not asking you to draw the x-axis in degrees. That is where you're finding it tough. Please use the radian values. Pi by 6 is less than pi by 4, pi by 6, pi by 4. Or you don't need even to split so much. Okay, so many angles you don't need. That's why I said take only these 45 degree I'm sorry. Take only the 1 minute, guys. Take only the 45 angles. This one 0, 45 degrees, 90 degrees, and then another 45, right? 135, and then what? 180 plus 45. That one, 180. Just these angles, if you take and draw the table and plot it, you'll get a graph. X-axis should be theta, y-axis should be cos theta or cos x. Does that make sense?
Yeah, that kind of makes sense. Thank you.
Dhwani, did you get it?
Yeah, so you just said that like we use the pi values as x and the cos values
Correct.
as y.
That's all I'm saying. You'll get a sinusoidal curve that is way different from what we drew. What did we draw? Let me show you. Let me put it here. So I drew it for sin x, right? I'll also put it here and show you the difference as well. My graph was, let me, wait. I'll draw my graph, you draw your graph. So I'm going to draw pi by 4, pi by 2, then 3 pi by 2, no, not 3 pi by 2, I'm sorry, 3 pi by 4. Then I have pi, then I have 5 pi by 4, then I have 3 pi by 2, then I have 7 pi by 4, and then finally I have a 2 pi. Same thing, I'm going to replicate it. Okay, I don't want to redraw the same thing. This is pi by 2,
Miss
this is
Priya,
3.
after you're done with that, can you check my graph?
Absolutely. 1 minute ma.
Okay.
5 pi by 4, 3 pi by 2, 7 pi by 4. You'll be amazed at how you follow in class after this is my thought. Okay, that is why I'm putting in a lot of effort. Basically, if you understand all these, right, you'll be way ahead and have more confidence. So here, what was our graph? We started with 0, and then what did we do? Again, I have to come to 0 at pi. So what did we do? We did a graph like this, right? And then the period, oh my god, 1 second. Okay, the period of the graph. So here it went here, and then it came here. This was our graph for cos, right? Now I am ready to, for sine, I'm sorry. For cos, I'm asking you to do. You can show me, ma. Perfectly correct. You got it now?
Yeah.
Yeah. So do you see the difference between sine and cos?
Yeah.
It is slightly. What is the difference? Meaning both are oscillating between 0 and 1. The parent graph is always oscillating between 0 and 1. There's no change because see, when you go around, right, what are you seeing? It's only like it's going up. When you see, let me only look at the sign. Half, 0.707, and then it keeps increasing, right? And then root 3 by 2 is 1.7 by 2. So it is a little increasing, and then it goes to 1. And after that, what happens? Again, it comes down to 0. Again, in the negative side, it rises. Meaning, it decreases because negative, right? It decreases. Goes to the lowest value. And again, it increases and reaches the value of 0. That's what we did for sine. But for cos, similar thing happens, but at different points in time. Can you try and tell me? If you don't get it, I'm going to wait till you finish.
Is it like decreasing and then increasing?
Yeah, correct. For cos, what are you saying, ma? Yeah, correct. Correct, ma.
Yep.
Go ahead. Did you guys get the graph? I will help you if you are stuck, but I want you to figure out. Advik, are you able to do?
I'm done.
Yeah, I've given you the values as well. I'm not making you suffer. I've given you the values as well. The thing is, slowly I want you to draw the unit circle if possible before the end of the class as well. I don't know whether that's possible. It'll take time because you're all new to radians itself. You want to show me, Advik?
Yeah.
You got it? Are you writing your... yeah, that's right. That's right, Advik. Are you writing your AP Pre-Calc exam this year end, Advik?
Yeah.
Oh, wow. Okay.
Miss
They
Priya,
start... yeah, ma?
we did this with transformations in class yesterday.
But that is what I'm going to go to today.
Okay.
You understood, huh?
Yeah, I understand.
Oh, nice. Oh, even the transformations you understood?
Yeah.
Good. Nice. Good for you.
Thank you.
Guys, did y'all get it? Krish, you got it? Shragvi, Dhwani,
Yeah.
Shri?
I'm drawing.
No pressure, guys. I can wait. But I really want you to figure out and understand it properly.
Miss Priya, so is it like the sine cos, like the opposites, like the direction the graph goes to?
Yes and no. Can you show me? It's okay to go wrong as well. Can you show me? You want to show me?
Like, I'm not done drawing, but I'm just assuming, like,
Where did it start, Dhwani?
the cos graph that that one starts at that one starts at 0, 1.
1, yeah. So the starting point is going to be a little different. That is what differentiate a sine and a cos graph. Advik, did you get it? Shri, did you get it?
Yeah.
Can I see the graph? Can I see the graph? Shall I go ahead or do you want me to draw? Shri? Shragvi, can I have whatever you have done? Lopa?
Miss Priya, can you check chat real quick?
What is it?
Chat.
Yeah, I can look at the chat. I'm sorry, I was not looking. I was wanting to see on the video. Yes, I can. Sorry. Okay, sure. Go ahead.
Thank you so much. Thank you.
Yeah. Shragvi. Tell me, Shragvi. You got it, ma? Oh, yeah. Nice. Shragvi, good job. That's right. Nice. So you got a graph like this, right? So at pi by 2, when you think about pi by 2 cos value, right? Pi by 2, this was 0, 1. Cos value was 0. Pi by 2 went to a 0. Now pi came to the maximum and then 2 pi went to the minimum. You see? Oh, what did I do, guys? I'm sorry. I don't know what I did. Okay. So pi came to the maximum and then what happened? The in-between thing is here, right? So it has to go through this and then see again what is the period? The highest point to the highest point was, that is your period of the graph. The lowest, the middle point to another middle point, again the period of the graph. So period of the cos graph and the sine graph is all 2 pi. Any questions? Okay. Any questions? Okay. So now we know how a cos graph and a sine graph came into picture, right? Now let's go ahead. Dhwani shared a problem with me. Let's do the problem now itself because it's very exactly similar to what we are doing. So why not, right? It's a nice problem school has given. So I'll discuss that and that's a good one for you all to go over as well, meaning to do as well. But I don't know how to share. What is going on? Give me 1 minute, guys. Okay, let me do one thing. I really don't want so many. Give me 1 minute. I'm not able to correctly share what I want to share with you. So please wait. I think I'm good now. Okay, let's see. Share. Yes, I got it. Okay, how about let's do this one? Are you all able to see the question, guys? Are you all able to see the question? There is a figure, a merry-go-round and a fence is there, right? Even I don't know the answers, okay? I'm just putting it out and we are going to solve it together. The figure shows a merry-go-round on level ground with a fence to its right. The merry-go-round goes around, rotates in a counterclockwise direction. The merry-go-round is going in a counterclockwise direction. and completes one rotation every 3 seconds. Meaning, let's say this is point B they have given, right? So the merry-go-round is going to complete the entire circle in 3 seconds. Point B is on the edge of the merry-go-round and is located as the furthest point, okay, t equal to 0. So that is the furthest point. Point B is the edge on the merry-go-round and this is the furthest part of the merry-go-round from the fence. From the fence, that's the furthest point when you look at it. Okay. Center of the merry-go-round is 10 feet from the fence. Center of the merry-go-round is 10 feet from the fence. Okay. And then as the merry-go-round rotates at a constant speed, the distance between B and the fence periodically decreases and increases. Right? Meaning, as the merry-go-round goes around, right? This is the furthest point, right? This is the nearest point, right? So when the merry-go-round is rotating, it's going to keep on changing, right? The center of the merry-go-round is 10 feet from the fence. As the merry-go-round rotates, it's going to periodically increase and decrease. Periodic function h models the distance between point B and the fence. Point B and the fence is the distance. The point B keeps on moving. Point B comes here, 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 right? And then point B comes here. Then again point B keeps moving because we are going on a anti-clockwise direction, right? Okay. Now the periodic function. Why it is called a periodic function? Because after finishing that one round in 3 seconds, again the merry-go-round is going to go for another 3 seconds. Krish, are you here? Now, what are we going to plot? We are going to plot x comma y, t comma h of t. What is this h of t? Let's see. Let's come here. So, f, g, J, K, P are 5 points that are given. Okay. Now, what are we going to do? Let's see. The graph of H and its dashed midline for 2 full cycles is shown. They have shown us 2 full cycles. Okay. I'm going to take this to this. That is 1 period. That's more than enough. We don't need more than that. Okay. Now, no scale is indicated, no axes are represented. Determine possible x comma y values. Right? X comma y values is what we need to see at points F, G, J, K, P.
Can I try doing the prefix and fix
Yeah.
fix them?
So at these points 1, 2, 3, 4, 5, can we try tracing this? Meaning the merry-go-round finishes one round in 3 seconds, right? So let's say this merry-go-round was at the farthest point. This merry-go-round was at the farthest point, point B. Let's say that it started there. So what happens? But before you do this, I can also show the video. The video is exactly this as well. Hold on. Let me try getting the video. I'm going to stop screen share. Let me try and then come back to this problem. Where did I keep? Yeah, I think I have. This is the video. This one is a good one. Oh, wait. Let me share. Where is it? Sax Lab. Yes. This is an animation I wanted to show you. So let's see. You can see. You see what happens? The distance is at its minimum. See, the distance is at its maximum now. So you see, let me. Are you able to relate this to the graph? Guys, are you able to relate this to the graph? Are you able to relate this, guys? So see, when theta is 0, it is here, right? When theta is pi by 2, right? What happens? See, theta is 0, and then again it has to return to 0, right? So here it returns to 0 here. So that is one full circle. When you look at it, that is one full circle of theta is 0. The value, you see, this is 0, this is pi by 2, this is again 2 pi, right? So basically one full circle is completed within 0 to 2 pi. So in between, again it reaches a 0 point. When you look at it, right, here, let me show you. What is the x, at this point, here it is 0, 1, right? So the max, let's see the video and then we'll go back. Wait. See, what are they color coding? Are you able to see? Cos is your x value, sine is your y value. Do you see? Meaning the rose, okay, let's follow only the rose color. We are going to follow only the rose color thing. Okay, so when we are going around the merry-go-round, let's see this point. I'll stop it. See, at the point 0, right? See here, the rose is exactly 0. There is no rose. Did you see? Meaning at this point, when you draw a right angle triangle, right, with the center, right, what is the x distance? I'm sorry, what is the y distance? We are doing a sine curve, right? So what is the y distance? The y displacement is 0 because it's all x only, right? So at this point it's 0, 0. Now I keep on going, my rose color graph keeps, meaning my y value keeps on increasing. Do you see here? I'll show you. The rose thing goes on increasing. See? Goes on increasing. At that point, rose thing goes on increasing. At this point, you see, you have only the y. There is no x at all. Do you see? Meaning, y is our sine theta. So at this point, pi by 2, what happens? This is your pi by 2. This is your, wait. Yep, this is your 2 pi. This is your pi. Okay. Now, this pi by 2 is here. Pi by 2 is where the x value, the y value is at its maximum. We are only discussing sine, only y values. X, y is cos and sine. We are only discussing the y. The rose color graph only discusses the vertical displacement to that point and the center. So now, when we are at pi by 2, we are here. When we are at pi, again, your vertical displacement on the graph becomes 0. See, the rose color reduces. See, at that point, it becomes 0 again. See, now, again, it keeps on decreasing towards the negative values. And then it comes to its minimum at which point? Let's see. See, now y is negative. At this point, y negative was at its maximum. So, this point is correlating to this point. Do you all get it, guys? Advik, are you following?
Yes.
Shragvi, did you follow, ma?
Yeah.
Now again, this goes on decreasing, right? This is your y value. So it goes on decreasing. When it comes here, again it reaches this point where there is 0 vertical displacement. Sine is always about vertical displacement. How about the cos value? Cos value is interesting. Cos is always about the x displacement. We'll concentrate on that once. Only the green line. Let's see. See, the x value is maximum on the x-axis. You see, x means we are discussing the cos. See, this is at its maximum. That's why it starts at 1. It's a unit circle, so the distance is 1, right? So I'm plotting it there. Again, the green goes on decreasing. It reaches the, let's see, that is the horizontal displacement. The green represents the horizontal displacement. Let's see. See, that point is a 0. The horizon, see, when the merry-go-round is here, right? When the merry-go-round is here, there is no horizontal displacement. That is that point. Okay, and then it comes to its yeah, let's see. See, the green becomes its negative maximum. The green is at its negative maximum at this point. So that corresponds to this. See,
I'd like to try to
that does it make sense, guys? Okay.
I'd like to try to do the stack thing with a list instead of a stack.
Sure. Okay, now I'll stop my screen share. You're going to do that problem. Let's see whether you're able to find it and then we'll move on. Can we try this one? Determine possible points for F, G, J, K, P. That means I really want you to write what are the T, H of T values. What can be the, yeah.
Do we put the points in like pi over 2 and like that, or just like normal coordinate points? Because that's what we do in school. We did like 1, 0,
Normal
like
coordinate point is
whatever it
enough.
is.
Normal coordinate point is enough. Dhwani, you know what? Yeah. So this is going to be what? T, H of T. See, the merry-go-round, let's consider here. Point
Wait,
B.
could you do this one? I have like 3 more problems that I can send to you for practice.
Sure. But did you understand how to do this now?
Like I understand like how to do it, but the thing is I have no way of checking the points I get.
Oh, checking the points you get. Okay, let's see.
Yeah.
Let's see. Yeah. Okay. Let's see. Describe the rate of change in which H is changing over the interval. Okay. I can do it later with you as well. But if you want me to do now, we can do. Wait. The figure shows the... Okay, now for every rotation, it completes. Okay. So, see here. This one, if I call it as T1, right? This will be... I'll call it as T1. This one should be T1 plus 3. Okay. Because it completes one rotation for every 3 seconds. So that's your period, right? Now, point B is on the edge of the merry-go-round and is located at the furthest part of the merry-go-round. Oh, point B. Okay. So, at t equal to 0, when t was equal to 0, it was at its furthest point in the merry-go-round. Okay. Point B is 4 feet from the center of the merry-go-round. So, let's see. Point B, this is 4, ma. So, what will be this point? 0. Okay, 0, 4. Let's say this is the 0, 4. This is the point B. Point B maps. Yeah, ma?
Wouldn't be 0, 14 because that's like the total distance for this to length of the fence.
1 minute, ma. What did the distance between B and the fence? Oh, period. Okay. And okay, I did with the center. So let's see. So it will be, yes, 10 plus, what was it, ma? 10 plus 10 feet, the center of the merry-go-round is 10 feet, and then point B is 4 feet from the center, right? 14, right, ma?
Yeah, that's what I said, 14.
14, that is 0, right? And after that, what happens? Which is point G. Okay, let's see. Wait.
Like, Miss Priya, since it's like, so like one rotation is like 3 seconds, so like point,
correct. Good
H
job.
would be like 1.5 seconds because that's like the midway between
very nice. 3, 14. So this would be what? This will
1.5.
Which
right?
one?
For the seconds, 1.5.
Yeah, 1.5 comma what?
Half of 47.
We need to be careful. Wait. Okay. Let's think about the merry-go-round. I want to see. Here it will be 14. Okay, that was the furthest point. When point B is nearest, how much will it be? 4 and then a 10. Wait. 4 feet from the center of the merry-go-round. Another 4 you subtract.
6 feet?
From 14 you subtract
because
8.
Like from the center to the other side of the wheel is 4 and then
good job. 6. Make sense?
Yeah.
Okay, now how to do this point?
That would be like 0.75 seconds.
Correct. 0.75 comma 0. This one would be the
Wait, why would
midpoint
it
of
be
3 and
0?
4.5 by 2.
Why would it be 0?
Why? Oh, sorry, ma. It cannot be 0. 0.75 and what? You know what? Wait, let me show you. I'll go back. Yeah. So we did see at this point it would
Like,
be
is it
6.
10 then?
This is 6. This is 6 distance. This was 14 distance, correct?
Mm.
This was 0. This was 3, right? Now in
Yeah.
between it'll be here or here, right? So the distance from point, what are they asking us to plot? The distance between B and the fence, right? So when the B point is here, what is this distance is what we need, right, ma?
Yeah.
So what will be that distance? It's not hard, right? It's Pythagorean theorem you need to do. This is 4. The radius is 4, right? The radius is 4. If this is 4, right? Then this is 6, right? Now, what is this distance?
So 10 maybe?
No. Pythagorean
Oh,
theorem,
like that.
10
Oh,
square plus 4 square, right?
16.
116.
So
Square root of
116.
116. You got it? This will be minus square root of 116. You got it?
Oh,
Does that
so we
make
do the.
sense?
Wait, why would we do the Pythagorean theorem?
Because see, the point B keeps on moving, right? The point B keeps on moving and they want us to plot the distance of B with the fence, right?
Oh, because it creates a triangle and like the
Yeah.
hypotenuse is D. Oh, okay, I see.
Yeah, for me, I was doing it from the center, so it was so easy. But here, if you want to find it, see, that's what I was also a little deceived when I started with. The distance B and the fence they're asking. You got it?
Yeah.
So it starts from 6 and then it keeps on, it keeps on, see, at this point it is, okay, we'll start with the latest point, meaning furthest point, and then it keeps on decreasing positively, meaning positive side it keeps on decreasing, it comes to 6. After that, it again keeps on, after that it slowly, see, this decreases till 6. So let me come back here. What happened here? So 0, 14, it came to 1.5, 6. 1.5, 6 is the nearest point from the fence to the point B. Make sense?
Focus.
So this would be 0.75 square root of 116. Square root of 116, is it between 6 and 14? Square root
It's
of 116.
between like 10 and 11.
Is it yeah. So we are good, correct. Then we are good, ma. Does that make sense?
Yeah.
It has to be between 6 and 14 and it is 10 point something or 11 point something, which is correct, ma. So it should be halfway, approximately. You see, it has to be between 6 and 14, that's it. So that is square root of 116. Okay. Yeah. Any questions? Any other questions? So this will be 2 point whatever, between what is the midway between 1.5 and 3 is this x1. y1 should be again square root of 116. Okay, I'll stop this here. Okay, now
like,
let's move.
The mid one is just the difference between like the y values of the first, the maximum and the minimum.
Yes, basically that is called the midline. This line is called the midline and it is halfway between the max and min value. Okay.
Okay.
So basically what did we have here? I'm sorry, what did we have
the
here?
halfway value like technically would be 10, but when we like actually calculate it for it's like 10 point
10 point something. Yeah, see, actually in a sine curve, right, when you look at it, right, so see here, the midline is this, right? So this is 1, this is minus 1, right? So basically you're going to find the difference between the two. 1 minus minus 1 divide by 2. So that is your so you're going to find the difference between the two values. Difference divide by 2. So here the midline is at 0 for you, correct? You're going to add both. So 1 plus minus 1 divide by 2, right? So that is going to be your midline. Does that make sense? Amplitude is going to be the difference. Midline is going to be, in your case, right, it was oscillating from 6 to 14, right? 14 to 6, right ma? So 14 plus 6 divide by 2, it would be, it should be a 10 actually.
Yeah, that's why it's like the midline, right?
Yep,
Because
it should be
14
10.
and 6, 10, right?
It should be 10.
Okay. Okay, then I think I understand it then.
Okay. Guys, did you all get how this merry-go-round translates to a sine curve? Advik, did you follow?
Yeah.
Okay, let's move on now. So let me do some transformation or some graph and then we'll discuss, okay? So I gave you this YouTube video. I'm going to delete this off. Okay. Now I wanted to go through, see, I closed everything. Hold on. I really wanted to finish at least the graph piece today. So we drew the graph of cos theta sin theta, right? Okay, so now I want you guys to tell me, okay, you're going to tell me where does sin theta increase, cos theta increase, where is it concave up, concave down. We are going to discuss that, okay? So now tell me, I will give you, we are going to discuss the characteristics of sine curve and cos curve, okay? So let's say you have the sine curve, okay? This is your sine curve, right? 0, pi, 2 pi. Now, in this sine curve, right, what is the period in which the graph increases? Here, and then what? Here. Where is this on this unit circle? Where does it increase? Increase means from start to pi by 2, 0 to pi by 2. So, during this phase it increases, and then 3 pi by 2. So this is pi by 2, pi, 3 pi by 2. Then it also increases from 3 pi by 2 to 2 pi. Makes sense, guys? So this is the area in this is the the time frame during which sin theta increases. Coming to where does it decrease? This is the period from pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2, it completely decrease. Any questions, guys? Shri, did you understand that? Parvini, you
Yeah, I got
understand?
it.
Now, let me change this and ask you for where it is concave up and concave down. Concave up, concave down. Where it is concave up and concave down. You guys, you tell me which is concave up. Which is concave up? Concave up is a cup, right? Concave down is this. Where it is
Pi to 2 pi.
Pi to
2 pi.
2 pi. Good job. Pi to 2 pi means concave up and it's a cup. So yeah. Concave down is here. Make sense, guys? Shagvi, are you able to follow?
Yeah.
Okay. Now I'm going to consider the cos curve. Let me put the cos curve. Otherwise, I need to draw. Otherwise, I can copy. Let's see. I will go with the cos graph. Okay. Sin theta concavity cos graph. Let me do the cos graph as well, please. Okay. For cos graph, let me draw the cos graph. What is going to be the cos graph? I'm going to draw it in another color maybe. That might help. So cos graph is going to be like this, right? It's going to be here. and then it's again going to be here, right? So it's going to come here, and it's going to come here, it's going to come here. So cos graph is this. So where is it going to increase? Let me put it as cos. Cos, where it is going to increase. What is the value when it is increasing? Guys, you're going to tell me. Where is the graph increasing? Krish, can you tell me? Where's the red graph? Red graph is cos theta. Where is the cos graph increasing?
Um,
You're not able to see. Okay. Where is the cos graph increasing?
when it hits pi.
Pi. Pi to 2 pi, right? So pi to 2 pi is where it is increasing. Where it is decreasing? Decreasing is 0 to pi. So 0 to pi it is decreasing. Now cos theta, where it is concave up, where it is concave down. Cos theta concave down. Where it is concave up and concave down. You tell me, which is concave up, which is concave down? It goes like this, right? So where it is concave up and concave down.
It's concave up when it's increasing and concave down when it's decreasing.
Yep. Concave up when it is increasing. Yes. But it will differ, right? See, okay. Okay. That's not directly correlated, right? Krish, it is concave up between pi by 2 and 3 pi by 2, right? Concave
yeah.
concave up between pi by 2 and 3 pi by 2. This is the cup, right? So concave up in which, let me draw, between pi by 2, let me put it in another color so that you get it. Pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2, it's concave up. This is the cup, right? Now this becomes like this, right? As a result, concave down in this. Concave up between pi by 2, 3 pi by 2. Here it is 0 to pi by 2 and 3 pi by 2 to 2 pi. Any questions here? So next week we'll work on graphs, graphing anything that's given, and transformations. We'll also finish with sinusoidal model, the sinusoidal function modeling. We'll finish the unit with that. Okay, I'll try to finish next week, do more problems as we move on. Any questions? Okay, if you don't have any questions, we'll stop here. See you all next week. Have a nice week ahead.
Thank you, Miss Priya.
Bye, Miss Priya.
Bye, guys. Ragvi, did you get what you wanted?
Thank you, Miss Priya.
Bye, guys.
Bye, Miss Priya. Thank you.
Bye, guys.